Hello students, welcome to EduWave online classes. Hope you all are doing well. Today we will be discussing about chemical bonding. So without further delay, let's start. When we talk about chemical bonding, three types of bond there are which are within our scope. The first one, ionic or electrovalent bond. This type of bond is having two type of name. Electrovalent bond. Next one we get covalent bond. Covalent bond. And the last one is coordinate bond. It is also known as dating bond. Okay, so if you are in class 9, then ionic bond as well as covalent bond will be within your scope. And if you are a student of class 10, then you should be very much aware of this coordinate bond. Okay, so within the series, you will get all the bonds in details within our channel. So please subscribe and press the bell icon to get all the types of all the videos that are being posted by all of our teachers for you. Today, we will be discussing in details about the first type of bond, which is ionic bond or electrovalent bond. Okay. So when we talk about electrovalent bond or ionic bond, the bond which is having two names, this bond is happening in between two elements, which is one of which is metal. I don't know why it's not working. Anyways, one of which is metal and non-metal. Okay. Now, if you talk about metal, then what is the number of valence electron? What are the number of valence electron present in metal? It's usually 1 or 2 or 3. And if we talk about non-metal, then usually the valence electrons are 4, 5, 6 or 7. Now here comes a point that why does a bond will occur? Why? There is a need of bond. So the answer is the bond occur because whether it is metal or it is non-metal, all the elements want to attain its stability. That means they all want to have octave state. Okay, what is this octave state? Like if it is a nucleus and this is the last shell, it should have 8 electrons in its outermost shell to attain the stability. And that is how it also try to attain the nearest noble gas electronic configuration. Okay, so as all the elements want to achieve this octave state or stability, that's why they either donate electron or accept electron. They are ready to do anything, but they want to attain this stability, and thus a bond form. Okay, now let us take a very relevant and easy example, our common salt NaCl. Okay, now see, from this salt, Na is my metal, Cl is my non-metal. So if you think that NaCl atomic number 11, its atomic number is 11. So what will be its electronic configuration? 2, 8, 1. Yes. If you talk about chlorine, its atomic number is 17. What will be its electronic configuration? 2, 8, 7. Now just see if by any way it can reduce this one electron. If it can be reduced, means this sodium atom can reduce this one electron, then it will have its octet stage. It will attain the configuration of its nearest noble gas, that is neon. So it is ready to donate this one electron. Similarly, now if somebody is donating, there should be someone to accept that. Now if you check out the configuration of chlorine, if it can accept one electron, it will also attain the stability and it will attain its nearest noble gas configuration, which is argon, okay, 288. So it is always ready to accept. Okay, so in this, one is going to donate, that is metal is going to donate electron, and non-metal is going to accept electron, and that's how they attain their respective stability and they form a bond, which is very strong bond. If you want to represent it, now sodium is losing one electron and becoming a cation. A charged particle is called ion, and if it is positive, then it is cation. Similarly, chlorine is gaining one electron and hence it is charging negative. Okay? So this is the thing that is occurring, and as a result, as one is positively charged, one is negatively charged, hence there is a strong electrostatic force of attraction between the two which is forming the bond, and hence it is very stable, which is giving us a stable compound called NaCl. I hope this one is very clear to you, and from here we can actually understand why this name, or from where does this name came. Ionic bond, because after the bond, the compound which form is ionic compound. Within this compound, there is a particular two ion present, cation and anion. Okay, that's why its name is ionic compound or ionic bond. Similarly, within this two ion, there is a strong electrostatic force of attraction. Hence, this bond is also called electrovalent bond. I hope till here everything is very clear to all of you. Next, what we are going to do, we are going to go for the same example, but now this time we are going to see how to draw dot structure or Lewis structure diagram. This is a very common question in I.C.S.E. Maybe for reference in class 9, I.C.S.E. boards are also using this dot structure, but a lot of question you can see the last 10 years paper you will get from dot structure. I will explain you how to draw this dot structure diagram. Okay, we are taking the same example, NaCl. Now, for drawing this dot structure, there is a rule. Sorry. Okay, so there is a rule. Now, if you are taking sodium plus Cl. Now, we are not going to draw everything or the whole atom, but we are going to draw only the valence electrons. So, in case of sodium, we have seen the number of valence electron is 1. In case of chlorine, the number of valence electron is 7. So, I am going to draw here 7 dots. So, we are just going to represent the valence electron as dots. Okay. Now by any ways, if this sodium can donate this one electron to this chlorine, then both will attain stability. And as a result, what will happen? As a result, what will happen? We will get a cation of sodium and an anion of chlorine. Fine. Hence, we will get a very strong compound or very stable compound of I.C.S.E. Understood? That this is how we are going to draw the dot structures. You can try out with any other ionic compound. We will also take another example as calcium oxide. Okay? Calcium oxide. So in case of calcium oxide, we will take this calcium plus oxygen. Again, we are going to draw just the valence electrons. For calcium, the valence electron is 2. Let me use this another color pen. Valence electron is 2, and for oxygen it is 6. Okay. So if anyhow this 2 electron can be transferred to this oxygen, then the both will gain its stability, and as a result we are going to get Ca2 plus and O2 minus. Plus minus, two different type of ions, hence a very stable compound of calcium oxide is obtained. So you can try with some whole lot of other ionic compounds. Just try out with potassium iodide or maybe magnesium oxide. So try out and let me know in comment section. Next, so like this, I hope I made you understand how or why this ionic bond takes place. It's a bond between a metal and a non-metal, where metal will donate electron, non-metal will accept electron, and that's why they develop a very strong electrostatic force of attraction, and then we get a ionic compound. Now after this, we are going to see how is the properties of this ionic compound. Let's see. Now we will discuss the properties. Properties of ionic compound. So the first property which we are going to consider is the one which will explain you rest of the properties. That is, this type of compound are having high electrostatic force of attraction. Why does they have strong electrostatic force of attraction? Because they are made up of iron. A positive charge is always going to attract negative charge. So they will develop a very strong force of attraction. Okay. Now next, let's see the next property. They are usually solid in state. So their state is solid. Why? Because of this strong electrostatic force of attraction, the particles will try to remain within each other or will try to be with each other, and as a result what happens, all the particles are very close to each other, which creates the solid matter. We know from very young age, we are aware that solid particles are very close to each other. They have very less intermolecular space in between and great force of attraction. So the same thing is happening, and that's why their state is usually solid. Okay. Next property, they have high melting and boiling point. Now just tell me, what is melting? Melting is changing of a solid state to liquid. Ice melts into water. That means we are changing the state from solid to liquid. Boiling is changing from liquid to gas. So if the electrostatic force of attraction is more or very much high, then it needs more and more energy to break the bond and change the state, isn't it? For changing from solid to liquid, we should increase the intermolecular space, we should break the intermolecular force of attraction. So that is why, as this force is more, we need more energy to break it, and that's what gives us the reason why the melting point and boiling point is high. Next, very important point, that solid ionic compounds are poor conductor of electricity. Okay, but in molten or aqueous state, it is very good conductor. Okay, now let us understand this point. How does electricity conduct? Electricity can only be conduct if there is presence of ion. Now you will tell me, ma'am, in ionic compound there is always presence of ion. Then why does not conduct electricity in solid state? Yes, it does have ion, but they are so tightly packed that they are not free to move. And until and unless the charge are moving, how will you conduct electricity? But when we are able to change its state from solid to liquid, that is in molten means just we are melting the salt, or in aqueous state means we are dissolving the salt in water. That time there is whole lot of ions present or available to move even. That's why it will be a very good conductor of electricity. Understood? So I hope this point is also clear, and this type of question is also common in your paper. Why does ionic compound does not conduct electricity in solid state but it conducts in molten or in aqueous state? So the all you need to write is, because of this strong electrostatic force of attraction in solid states, the ions are not free to move. But when we convert them into molten or in aqueous state, the ions are very readily free to move and conduct electricity. Fine? Hope you understand this point as well. Okay, now fifth point. Fifth point is solubility. So ionic compounds are completely soluble or very much soluble in water. Soluble in water. Now for explanation of this portion, you need to know that water is a polar compound, which I will be teaching you in our further videos. But okay, ionic compound when breaking down or dissociates, it will have its cation, a cation and an anion. Now when it is inside water, when it is being dissociated, the ions are being dissociated, water being polar completely surround it and makes it fully soluble. Understood? So this is all for the today's class. Hope you enjoyed it and understood all my explanation. I'll be coming soon with the next two portion, that is your your covalent bond as well as coordinate bond in our further videos. So for that, Keep watching our channel. Follow us on YouTube as well as on WhatsApp. And the link for our WhatsApp channel is provided in our description box. So hope you all enjoyed the class. See you soon. Bye bye.